A fault-tolerant and scalable boosting method over vertically partitioned data by Zhang et al., published in CAAI Transactions on Intelligence Technology. Welcome to Journal Club. I'm Malcolm Diggs. Imagine that you're a bank, and you've got a fraud problem. People are signing up for your credit cards with stolen identities, racking up charges, then disappearing, and it's costing you a fortune. It turns out, the fraudsters are doing this all over town, all over the state, all over the country. It's not just a problem for your bank, it's a problem for all the others as well. So one day, you and the other bankers decide to get ahead of it. When a fraudster hits one of you, you'll share the fraudulent transaction data, user information, and behavior patterns with the group so the others can be on the lookout. Or at least, that's what you want to do. But there's a problem. Privacy regulations prevent you from directly sharing raw data with another bank. You can't guarantee that all the information you're sharing is about bad actors. There will undoubtedly be some good legitimate customer data accidentally swept up in what you're sending back and forth to each other. But sharing that data without customer consent is a big no-no. Your legal team says, no way, folks, we are not doing it. It's a non-starter. So, what can you and the other banks do? How can you as a group share learnings without sharing data? Instead of sharing user data, each bank independently trains a local fraud detection model on its own transaction data. Then, instead of sharing the data itself, each bank shares encrypted updates such as pattern insights and model adjustments through a secure central server. This central server aggregates the information from each bank to build a collective fraud detection model that reflects a wider range of patterns without exposing any individual bank's data. What I just described is called federated learning, the process of training a shared model across decentralized datasets, allowing organizations to collaborate without compromising data privacy. Today's paper is all about federated learning. In it, the authors present a technique that overcomes some of the thornier issues with federated learning, in particular something called the straggler problem and some common impediments to scale. We're going to get to all of that, but first we need to cover three core concepts: federated learning itself, partitioning, and boosting. Federated learning is a